Okay. Just wait for local share, please. Can you go to your... Thank you. Okay, so hello again. I am Antonio Virdis from University of Pisa, and we are going to talk about automating large-scale simulation and data analysis with OMNeT++. This is based on a work that we submitted to this year's summit together with Carlo Vallati and Giovanni Nardini, the three of us are from the University of Pisa, and this is the panel version of this topic. So the structure for this panel is a little bit different and not that different from the usual. I will start with briefly introducing what we discussed in our paper and what are the simulation phases that we are all, I think, all familiar with, and then discussing the differences between parameters and factors. Then we will have the actual panel with 5 topics, 5 main topics, depending on the time that we have. We have 45 minutes in total, so we will see. The general format is for each of the topic I will suggest to the panelists and to all the whole audience a general idea of the topic itself and a few questions. If you have any other question or comment, you can of course raise your hand and ask for them. However, as we have not that much time, this is just kind of an old introduction for the general discussion that we will probably have during the rest of the community, as it seems that this is an hot topic. So, so far we have our panelists here on the, actually, in red corner, but we are separated. So on the mixed corner, we have Laura Morifini from Uppsala University, and I will try, as I promised, the Joseph, Kyung-Soo Kim, Joseph from Siam Yantong Liverpool University. Perfect. Thank you. And on the blue corner we have Andras, Varga, and Rudolf Ornig. Both of them are from the OMNeT++ team that you know. So, as I said, you will, for each topic, each of you will have around 2 minutes. So, let's start for something that we probably all know about. Where are actually now? We are at some place in time. We have an idea. So we decide that we are inventing some new protocol or some new algorithm, and unfortunately the research community do not believe us, so we need to demonstrate that. What do we normally do? We have a modeling phase where we are creating our model, developing our model, and deciding what we need to put on that. We have, of course, a development phase where we are implementing this model into our favorite framework, for example, let's say OMNeT. Of course, we have our documentation phase that is pretty important. It takes a lot of time during our process. And we have the validation and verification phase. Okay. At this point in time, we are ready for performing our set of simulation. Basically, this means that we have modeling, development, and validation verification in place that are completed. We have a pretty good idea on what we want to test, so what kind of scenarios we want to test, and a good idea on what we want to measure, so on the metrics that we want to measure. Okay? At this point, we have basically 4 new phases within the simulation process. The first one is the generation of the scenario, so the selection of which kind of networks of deployments we want to simulate. We have to deal with the execution of the simulation itself, so how to perform that if we have a single PC, multi-PC, multi-cores, or stuff like that, distributed or similar things. We have to deal with result management, so how we can write these results into files, into memory, what kind of format, and how we can read them in order to process them. And finally, we have the results analysis phases. Okay? When we generally are going to do a statistical analysis on the data, and we need to plot some kind of cool charts of that. So, in all those processes, in particular in the first one, we have to deal with factors and parameters. What do I mean with this? Let's suppose we have some general type of node, call it for example Frank, that has some kind of mobility capabilities within our model and is able of sending messages. Let's suppose we decide that in our old simulation we will keep a rate of 50 packets per second, and we are deciding that it has a mobility that is linear. So those parameters are fixed and will stay as they are during the whole simulation process. So we call that non-varying parameters or parameters, simply. On the other hand, let's suppose we want to test our system and look at what happens whether we vary the size of packets, for example 50 or 100, and the speed, the mobility speed. Okay? And those are varying parameters which we call generally factors, and are usually represented using iteration vars in OMNeT. Okay? Maybe you are familiar with these kind of things. So we have the distinction between those two sets of elements and how we can manage them. The OMNeT actually is pretty cool with this, and if you have two factors, for example, with two values, it does the Cartesian products of those values and obtains, in this case, a set of 4 simulations. All these lines are something like the fingerprint of the simulation itself, and are also represented by an ID, a run ID. The main problem with this is that if we add, for example, we need to reach statistical confidence, statistical soundness, for example, we need to increase the number of repetition. What happens in this case is that OMNeT also uses the repetition ID, which was 2 and not 3, okay, as an iteration variable. So it actually changes the association between the fingerprints, so those parts here, with the ID. And this might become a problem when you are dealing with a lot of simulation. Okay? So in our paper, concluding this part, in our paper we proposed some kind of architecture which was encompassing all the phases that I talked about so far. The shared generation, the managing of lancing, simulation, parsing, writing and parsing results, analyzing them. And just because we are generally going to use the factors to identify as a fingerprint all our simulation, our idea was, shall we use factors to kind of identify our simulation for the whole process of phases, starting from the scenario generation that will identify factors and then communicate them to all the other phases, whereas parameters are just needed at the beginning. Okay, so this was our view of the original architecture. So, just for warming up for the topic, for the panel, let's start with the kind of topic number 0. What is actually a large-scale simulation? When does a simulation become large? From my point of view, it becomes large when you have a lot of modules, either compound or simple modules, lots of metrics, or lots of factors, as we defined that before. In the first 2 cases, we are just defining the size and large size of a single simulation. Whereas in the last case, we are defining the number of simulations we are performing. But I think from my point of view, a simulation becomes large just if only one of these things holds. Okay? Maybe I'm not actually asking you a question right now, so please keep in mind this when you are answering the other during the other topics. Okay? And if you think something different. Okay. Let's start with the scenario generation topic. I said that factors are really important from my point of view. Do you agree with this? And should we keep an ID-based association between simulation and the actual factors, or use something like a factor-based naming. For example, what happens if I just add a new value to my to one of those factors? I'm going to change again the numbering of the ID numbering of the simulation. So how we can deal with this? And okay, that's all. So maybe Joseph, can you start?
Yes, maybe I can start this naming issue, because we had some intense discussion last night during our casual dinner, especially with Antonio, myself, and Andros. To me, I think this is not that important, ID-based or factor-based, because current ID-based the naming scheme inside the OMNeT++ is quite machine-friendly. It's definitely not human-friendly. It's lots of long daytime, blah, blah, something like that. But that doesn't matter, actually, because to do some very systematic statistical analysis, we definitely need to use some additional package, especially, for example, statistical analysis, R is definitely de facto standard among the statisticians. Then fortunately, the OMNeT++ has an external module exporting all those simulation data into R's fantastic data frame object. Okay? So once all simulation results are imported into R's data frame, which is also available in the Python through the pandas module, then suddenly this ID or naming, whatever, is not that important at all. Once we have this whole set of the simulation data inside the data frame, we can dissect whatever dimension, grouping, whatever factor or whatever. It's just a matter of the command. So current the naming scheme inside the OMNeT++, as I just said before, motion friendly. But the point is that once this whole data exported into some nice data structure, which is data frame, then suddenly this naming scheme or ID, whatever, is not that important. So I can just regrouping, okay, I just want to regroup whole simulation results based on factor 1, regrouping into factor 2, or regrouping as a vector of the factor 1 or factor 2. I have a full freedom of the regrouping, dissect, or whatever in my statistical analysis using R's data frame, which is also, again, available in Python and many other languages. So my point is that naming is maybe not that important as far as we can identify this row. Okay, each row is identified this ID. Each row is consistently stored in the data object. Then IDs may be human-friendly, motion-friendly. My opinion is maybe not that important.
Okay, thank you,
That's
Joseph.
my take, yes.
Okay, good. Rudolf, anything on this?
Joseph may have right if you take the analysis step in view, but if you think about what happens when you are trying to run actually the simulations, if you run everything at once, then it's not a problem, but probably it's a problem if you want to somehow run the simulations in several steps, like you are doing some kind of interactive I mean, you are trying to explore the parameter space, and then it would be really useful to have some better control on what is, because right now, of course, there are tools or command line options in OMNeT which could actually dump out the mapping between the run ID and the factors. But currently the problem is that if you are interactively change something like you add a new variable or a new value, then the numbering is, the association is broken, so you have to figure out again that which run number belongs to which parameter combination, which could be manageable. You can dump out and parse the output, and you can write some scripts, but maybe it would be much better or easier for the users to just say that, well, let's try this value or that and add something like. Obviously, if you add new parameters or factors, then you are changing the whole thing, so you can't expect to be able to do that in an incremental way, but sometimes it's just easier to try one data point and then try something other just to have the feeling. I guess at the end you anyway run the whole simulation somehow, so it's not that problem at a later step on the analysis, but probably would be much better, or we should have much better control on this. Of course, you could write or you can write tools for this right now, but out of the, I mean, it would be much better to have it, yes. Okay. And there is another thing which could be also worked around that. Right now, by default, the result files are, the file names itself contain the run ID.
I have something about this.
Which could be quite confusing if you are changing things around, but that could be also overwritten right now. It's just not the default. Maybe it's a bad default.
Okay, thank you. Laura, any talk from this?
So I think that my colleagues have already said a lot of interesting things. I think I would push back a little bit on this distinction between a factor and a parameter, because I changed my mind a lot.
Okay.
The idea that you have some parameters that you have parameters that are fixed and you have factors that change, that can change over time. So you think that certain things you want to be fixed, you explore some space, you say, okay, I want to fix these parameters, I want to keep these parameters open. And so I was thinking about a feature I think I'd might like OMNeT to have. I haven't thought it through all the way, but the right people are here. I would like some mechanism to dump all of the parameters associated with the simulation, including the ones that have default values set from NED, either into the SCA, into a results file, or into some parallel file structure, so that I don't have to go back and say, oh, I have to go back to the source code tree to figure out what the default value was when I ran the simulation, because that wasn't unless I explicitly record that as a record scalar, because now I end up with modules that have 400 record scalar calls in them, because I'm trying to save out all of the parameters. So I think it would be nice to have a way, a systematic way to simply say, possibly to maybe star map star, all of the parameters associated with the Mac. Just dump all of them somewhere. Defaults, whether they're defaults, whether they're from your factors, put them somewhere.
It's just like doing.
And then I can always associate them with the simulation. And I'm wondering if that's a good way to address some of these issues, because then the run can just be a UUID, and that can be associated with the UUID that's associated with that complete parameter dump. And then you know all the parameters, and you're not worried about this changing. I haven't thought it through all the way for what, but I'm wondering, because at least for me, I just end up with these modules that are full of record scalar, just so that I know I can get tightly associated to the results, the dump of all the parameters.
Okay, thank you, Laura. Anders, with a slightly smaller additional question regarding this. Hearing what Rudolf said about finding a way of managing factors when you would like to run a single simulation, for example, do you think would it be possible to have something like a per factor identification of simulation during the launching rather than saying run simulation number 2?
So there's a purely technical question here, like the question about file names. The file names are named like scenario name -0, 1, 2, 3, 4, 5. But that's just a default. Everyone can change the default file names. And as Rudolf said, maybe this is the wrong default, because yes, when we have sequential numbering, then it's very difficult to add new iteration variable to identify which file is which, contains which results, and so on. So a better naming scheme would be to have the values of the iteration variables in the file name. Then the files would be like self-describing, it will be easier to identify the files. I also agree with Joseph that once we get to the data analysis phase, when all the results files are self-describing, then one can import all the files together into R or Python or something else, and then the file name doesn't matter anymore because the data are self-describing, and you see all the data from all your 1,000 runs in one data structure, and you can select whatever you want and analyze them. As we had some early feedback before the workshop, so we have done some prior work. So we have an experimental implementation of this file name change. Only drawback is that file names can be really long.
Yeah, that's
But,
very-
well,
yeah.
It's a matter of personal preference, or I don't know, file system limitations, what it allows.
Can I make a technical comment on the
Yeah,
names
sure.
or something? Right now, there's issues is that to make the file naming is more systematic, so that humans can easily identify which run is for which parameter factor, blah blah. But right now, we are discussing or having this panel discussion in the context of the large-scale simulation.
Yep.
Okay, small-scale simulation. Even though with the current ID, with some little bit of effort, you can easily identify. Okay, this run ID for which parameter factor. Let's say maybe you have just maybe 10 simulation runs. Okay. But in my case, for example, I had to run about 3,000 or 4,000 simulation runs for one just experiment. So in such a case, it doesn't matter how human-friendly or systematic kind of naming, whatever. All I have to do is just simply export star. This is a regular wildcard name, am I right? Star.sca. That's all. I don't have to type a specific file or whatever because there are 3,000 or 4,000 scalar files I have to deal with. So all I have to do is that OMNeT++ R export tool over star.sca. So in such a case, in a large-scale simulation where we have to deal with hundreds of thousands of scalar files, again, as I said before, intention is really good, but in the context of large-scale simulation, file naming is definitely not that relevant. Also, technical issues. With the systematic naming, as Andres pointed out, that the file names becomes really, really large. I found out that Git may be okay with the long, large file name, but sometimes, because I have the public repository at the GitHub, and some local change, I don't want to reveal all the commit log message into the GitHub, so I just maintain my personal repository through like Dropbox or something like that. Then suddenly you have the problem with those long file names.
Mm-hmm.
They cannot synchronize with such a long file name with many different hierarchy directories. So I still prefer short file name, even though maybe quite difficult to identify by human point of view.
Maybe we can get back to
Yes,
this
yes.
in one of the next topics.
I
Yeah.
would want some comment on scenario generation.
Mhm.
You know, about parameters, I think a long time ago in OMNeT there was an option to save parameter values into scalar files, but I haven't used it for a long time, so I'm not absolutely sure it's present, but it rings a bell.
I don't think I've ever seen something documented in the current documentation.
It's probably listed, but it's not
It
Save
is the
parameters
data.
as scalars or something like that.
save parameters, scalars, something like that. And about scenario generation, so OMNeT contains these iteration variables, which produces Cartesian product, and one can add also a constraint which takes a subset of this Cartesian product. But I think if we talk about really large-scale simulation campaigns, then we maybe need a different repetition count for each data point. So we run a few simulations, and then we measure the accuracy with some statistical analysis tool, and maybe we will decide that, okay, we need another 5 runs to reach accuracy, or maybe we are running a simulation with, I don't know, 5 nodes, 10 nodes, 20 nodes, 50 nodes, and so on. And then in the middle, we run some certain analysis, and then we determine that there is some interesting change happening between 10 nodes and 50 nodes, and we want to refine the resolution. So I think it also has some significance to be able to generate new values for iteration variables, so new data points for a study. And for this kind of thing,
Without running the rest or the already
rerunning the order.
Yes, without rerunning, yes. So this is like, this problem has two parts. First, there has to be a simulation control thing which looks at the results and decides what needs to be added to the data points. And another thing is that we need to be able to run the missing runs. We need to be able to identify which simulation runs need to be executed and run them. And OMNeT also needs to be extended. I mean, we have extended it in the last weeks so that you can select which runs to execute just by specifying the value for the iteration variable. So you can say, run all the simulations with number of hosts equals 15 and load equals 5.
This is another topic.
Mm-hmm.
In fact, we actually covered not all the topics, but almost just using the first one.
I'm sorry, so to implement this, is there some kind of an indexing system? Is there like, because you don't see like it seems like maintaining some kind of an index or database
Maybe.
would be one way to manage this sort of information.
Sorry, Laura, can we talk about using the next topic? Otherwise, we are. Okay, so as the next topic, actually, we are something we already started discussing right now. The problem of executing those large set of simulations. There are actually OPP run and OPP run hold that are available within OMNeT for running from batch running a simulation from command line. And maybe the only problem with those is that they work only on a single configuration. OPP run all, if I'm correct, works only with a single configuration. So if you want to run more than one configuration altogether, you need to launch two separate instances of OPP run whole. And how we deal with a large number of runs, possibly using multiple core. And another hot topic, maybe you heard about Akaroa, and you think is the favorite song, the favorite tool to be used in this case still, or other ideas. And finally, something that Andras was already citing, do you think there is a need for a dynamic stop criterion for stopping simulation? For example, when a certain statistical confidence interval is reached, either from a simulation duration point of view or from a number of simulation point of view. Okay. I think for just to be fair, Andras, maybe you can start on this.
Mm-hmm. Okay, so OPP run basically runs one simulation as an executable. There are two options here, actually. If you have a number of simulation runs, you can run them as separate processes. You run just several programs. But if you use CMD-env, CMD-env can execute several simulations also without exiting the process. And we have found that if we have a large number of simulations, but they are very short, so if the simulation is done within a couple of seconds, then one can spare a lot of time by running all of them within the same CMD-env instance. But this assumes that the program has to be entirely clean, has to have the proper cleanup code and reset all the global variables. If it uses, it shouldn't, but if it uses, it should be reset and so on. Otherwise, we get some interdependency and false results. Okay, the other thing is Opera now is basically just a simple tool. It generates a make file and new make, and it utilizes new make's parallel build capability. So you specify -J6, for example, and then it will run 6 simulations in parallel. It will keep 6 simulations running, and when one of them terminates, it will launch one to replace it. Well, so OpRunL is basically quite a simple tool, but it can exploit multi-core CPUs. So it's a simple one. Well, if we have larger simulation campaigns, like we have a cluster, available cluster, then one can use some external software to some job queue software optimized for this purpose. We talked about this last night, and 2 of them looks very attractive. Like there's one called Condor, and the other one is SunGrid Engine, and they are both open source software. So one can set them up on a cluster, and one can submit jobs to them, and they will execute these jobs on the available cluster nodes. And I think they can also collect the results to a common place.
Thank you, Anders. Okay, Laura, any thoughts on this? Considering your experience
I think generally I run, I think that when we run large number of simulations, I tend to get machines wherein as I can, so they're not quite as organized as a cluster. And I think that unfortunately using commercial clusters, I don't know if anybody's tried running on Amazon or on Amazon AWS or something like that, is the problem is that you can generate so much output that the compute is very cheap, but getting the data back, because you don't pay very much on Amazon for the compute time, but you actually proportionally pay a fair amount for the data movement, and that's actually what I find is expensive in terms of. So I tend to sneak OMNeT processes onto whatever machines I can, and then I get in trouble when something didn't clean up properly, and I take down a machine that had all memory after running for 3 weeks. But that's something I'm interested in seeing other people. People should participate here and not just listen or read their email or whatever. Do people here run on Amazon or something similar to Amazon when they're running big simulations, or they have local clusters?
maybe you can just start answering now. No, you can, please go on.
Okay.
Yeah, that's my.
I was fortunate enough to a huge Linux cluster as my personal computer when I was at Swansea University. So not many people actually utilize the Linux cluster because of those scheduling and supporting software. They simply don't want to spend their time to learn. So I'm just using this 192 core, a huge Linux cluster as my personal piece at that time, several months. The first question, how to deal with a large number of runs. My point is that that's the job of the specific system, like the SunGrid engine, which is right now become the open grid engine, because the Sun is no longer exists at all. So open grid engine for specialized Linux cluster, or heterogeneous kind of the computing cluster, in such a case, the Condor from University of Wisconsin. These are two different type of the clustering computer something. Then my understanding is that this deal with large number of runs over these cores and the different system is job of that kind of system. They have their own batch and an array scheduling and handling system. So in my case, I never use OPP run at all, because I only need to write down just one specific run with a configuration run. So I need to have some sort of a shell script. Then generating this one, and this should be handled by SunGrid engine or the Condor. So that's their job. So what I'm saying is that rather than just run all the configuration or the run, no, that's not the job of the OMNeT PP or anything else. We just need to specify certain spec runs programmatically. Then this grid engine scheduler taking that input and then change it into its own job file or scheduling file. So the point is that deal with a large number of runs, we need a separation. OMNeT PP just focusing on the one specific run with configuration. Then this is translated into the job scheduling and submission by specific system. It's different from system to system. So again, my point is that OMNeT++ doesn't have to be covering that as much, because this is quite specific to system. Carlo, your favorite son, we already had discussion. Yeah. So we just simply, Carlo is really good on the paper, okay? The systematically analyzing and the stuff on the runtime online. But my guess is that most of us are just simply using rule of thumb, okay? Maybe an M1 queuing system, maybe 100 packet arrival is more than enough to get good results. So maybe Akara is really good, but in reality and practical simulations, not much used. Need for dynamic stuff criteria.
Okay, maybe we can ask Rudolf if
okay, yes.
if something
that's
about
my point.
from this, in particular for this part, for requesting a dynamic stop criterion. For example, deciding dynamically the number of repetition.
Well, I don't have strong feelings about it. I mean, I don't know, I don't have experience because I'm actually not running large-scale simulations.
But this is something that might be even...
yes, what I feel is that as long as the OMNeT supports to, I mean, you can incrementally run simulations and specify a single simulation run, you can either deploy it on a cluster with its own tool, or if you have some specific needs, like some strange exploration strategy, like you don't want to go in a matrix, but rather, I don't know, some approximation on the parameter space, or you want to incorporate some stop condition on your own. I mean, you don't want to say that I have to run this 20 times, but rather some more specific conditions. Then you can write some kind of script. Even without a Akaroa, for example, you can run a simulation run and then run some small analyzing stuff in the script, decide whether you continue. If it's not okay for you, then you can continue and running further simulations. So I think that as long as you can run and specify a specific OMNeT run, you can script this whole thing.
Okay.
I can't figure out something which is generic enough and useful enough and covers everything. It's just.
I think we can get back to this. Yeah, sure. Please.
We have this so-called model with result managers included to tell later about it, but there we have also a constraint check result manager, which you can write constraints, and all violated constraints would be written out in an extra file, or you can say stop the simulation if this constraint is violated, because we analyze in-car architectures, and when we say this delay must be hold, don't be violated, then we can stop the simulation because other results are not more interesting.
Okay. Thanks. Okay, I think we have a lot of material on this topic. I think the next one will become probably the last one, and because we are running out of time. Just to conclude, so with one of probably the most important, most challenging part when performing simulation, how we deal with writing and reading results. Actually, OMNeT gives us the scale tool that is used for analyzing, for parsing results, and comes even with a graphical user interface. They both parse results using our regular expressions, so you can use that either by command line or by graphical user interfaces. The main problem generally in this case is that results are fully loaded in memory, so if you have not that large amount of data to be analyzed, the graphical user interface starts to collapse, and even if you do that with the escape tool, the command line, you can even end up with using all your memory, physical memory. So that might be an issue. Do you see any alternatives? I am adding this, implementing, for example, new writers, because I talked with other researchers about these that are working on implementing new writer, and I think Rudolf will give us a talk about using SQL, yes. And finally, maybe this is the topic we already talked about, connecting results to factors, and this is the example I was talking about. Normally what I do when I define the scalar files, I use this very long string for just not using the run ID. This is basically doing exactly what I did in the table at the beginning. So using the configuration name, run number, all the iteration variable, and the repetition. So depending on what your preference in this case, you can change it to one. But I think Andras was referring to something like this before. Okay. I mean, now which one? If you have any specific comments on this, you can start. Whoever first. Rudolf, maybe you.
Just a quick question: how many of you have used or using regularly the analysis tool in the ID for just quick check of the results?
A lot.
Okay. So because that was actually meant to be doing some quick checks that everything is running, not for publication ready stuff. But generally,
in this case, if you have even a large set of results and you want to do a quick look up a portion of it, you have already them in memory, so this is a problem even in that case.
Yes. Obviously, the ID and the SCAF tool have some scalability issues, which could be resolved. So it's probably something we should look into, because there is no reason. I mean, they are just scalar results, so it's not a multi-gigabyte something. It's much harder to keep all the vector stuff in memory, but that's not the case here. So probably this could be addressed. I mean, regarding the ID stuff. As for other formats. As you said, I will have a presentation, so I won't go into detail.
I'm setting this because maybe it was Christoph Sommers who taught me about using a format for big data. It was HDF5 or something like that. So maybe that is another alternative. Okay.
I have one issue with this upper right corner, the 4 boxes. Because this picture is showing that the whole development phase is just one directional, but as we all know that any of the not just a simulation is kind of spiral. So for example, we just did one pass with some prototyping or the small scale simulation to check that model is right or the scenario is right or blah blah. So in such a case, as we don't mention that, all the existing GUI tools or whatever inside of OMNeT++ is more than enough. As I said before, I ran this in 3,000, 4,000 runs, but I didn't do using the GUI or escape tool with the 3,000, 4,000 scale files at all. Definitely not. But initially, I'm just definitely reducing to just 10 runs, 20 runs, so some representative configuration. And as I said before, existing OMNeT++ tools and the capability is perfect. There's no scalability problem with just tens of the scalar files. Then I just verified that my scenario is quite good and the model is quite good, validated. Then I just again back to scenario and then generating 3,000, 4,000 scenarios. Then starting from there, no longer there's no room for interaction at all. This all should be done in the bench offline. So it's kind of spiral.
You mean you are adding new scenarios manually?
Not new scenarios. Initially, I just generating only some representative 10 or 20 scenarios out of the maybe thousands of the scenario space. Then once I just verified everything, then finally generated 3,000, 4,000. Like maybe x-axis, you test it with the 10 points. But eventually, I just want 100,000 points on the x-axis alone. Am I right? A simple example. So in such a large-scale situation, my understanding is that there's no room for interaction at all. Everything should be done on the offline and bench processing.
You just said that when you are going back and adding new values for the factors, you are doing that manually. So this is the reason why the arrows are pointing that direction.
Manual is maybe not the right word, as I said before. Once you just run 1,000 scalar files, and then from the scalar files you exported all the data into R or Python's data frame. then I have actually much better capability than this OMNeT++ GUI interface. Much better flexibility.
Yeah.
Yeah.
I agree.
One more point, just a technical thing that we are so far we're all talking about a scalar. Every simulation run putting its data into a separate scalar file, but it's also possible to for new runs append to an existing file, and then you can have one file collecting all the results. Well, it has advantages and disadvantages as well, because then file names can be shorter, of course. There are less files to manage, but also we are mixing up results, and it's more difficult to delete things from the result file. I just want to ask if does somebody use one file for all the simulation runs? You did? Did it work out well, or you prefer separate files?
Well, I really use this kind of result management that I've written my own tool to generate this result files, because I'm only interested in certain parameters. So it's not 3,000 simulations, but 20 or
It depends on the scenarios. You use an interactive phase, definitely may be better to include every scenario, the results in one file. But again, when you run with those cluster container heterogeneous system, each run should, how can I say, input file, output file per each run. This input file, executable output file should be packaged as one unit. Then the whole control is done by this batch scheduling or whatever. So, OMNeT++ or even what is that, Akaroa cannot be into the picture. Once it's submitted, and then you lose the control. So in such a case, multiple results into one file cannot be workable.
Okay.
Yeah.
I think it's probably, I just want to point out that we've kind of been focusing on many scalar files. There are actually classes of simulations where you have very large vector files. For example, battery discharge over and I think the issues there is dealing with these very large that even a relatively small set of simulation runs can generate extremely large file outputs. Yeah.
Okay. Thanks, Laura. We are running.
If you are ready, we are also ready.
Okay, just to conclude this discussion, we will just skip this part. I was saying that we love actually the graphical user interface. I think most of you love this. And the general message is that most of us have different preferences on what to use for analyzing data. For example, do thousands of scripts for uplot or using R or stuff like that. I think that the big challenge in this is what we were trying to think about in the paper. By hearing all the comments from the panelists, the general message, which I agree with, is that OMNeT is already pretty good in organizing, in letting you organize your own work. Maybe the only problem is that as researchers we have a lot common problems when dealing with simulation in general, not necessarily large scale. So maybe a challenge might be not defining those single boxes, like saying, okay, this one should be Akaroa, this one should be R, or this one should be something else. It's just maybe we can discuss something like, can we define interfaces between those blocks and just say, okay, I will use my favorite one for this one, but I can use all the other available in the literature, or maybe the one available for OMNeT for the other steps. As far as I respect, as I follow, let's say, the contract between those elements. So from my point of view, this is the real big challenge that maybe we should take a look at. So just before concluding, if you, just one of you have a comment on this, otherwise we can.
Well, Jenna, I think there are two points where the interface might be interesting with the parameter and scenario generations, which is pretty simple because at the end you will end up just with a command line which starts the actual simulation. So it shouldn't be a problem. Right now the only interface is that you can specify the run number and it's done. That could be a bit extended or make it more useful. Now the more interesting part is between the actual running and the analysis. Let's call this is the parser, which is really not something parser, it's kind of converter, because OMNeT outputs text-based result files, and if you cannot analyze that with your favorite package, then you should have some kind of converter. So we should speak about or think about something like having a better output or better alternative output, which could be used with a more analyzer tools out of the package, because if you have the OMNeT R package compiled and whatever, then you can read in the files. But if you want to do it in Python, where parsing the vector files and scalar files is a bit harder, so we should discuss the output.
Okay.
I think.
So, just before Vladimir kills us all, running out of time, I would like.
It's getting colder, you know.
Okay, I would like to give a big thank to the panelists for joining us in this discussion, and all of you for at least trying to interact. And I hope this will trigger and we can continue the discussion on this. So, thank you all.
Okay, the lunch is prepared. There was a coffee break. I will just ask you before taking the lunch if I can ask you for a contribution in amount of €8 or 200 crowns. This covers lunch, which was around the €5, and also the coffee, cookies, and the other bars for today. And I will ask my colleague Michal, he will tell you which box is what kind of foods you ordered. So, prepare.
Thanks a lot, guys.
Actually, it's a really interesting paper.
Yeah, actually, it went even better than I thought. It was pretty interesting. The only problem probably is that it will need 3 hours for discussing this.
So I started getting an idea. Supposing I'm collaborating with a bunch of people, physically distributed, and we're sharing up our simulation results. So I didn't think about this so much. I'm sorry I didn't join for dinner last night. So supposing I have a distributed collaboration team, we're all different places, we all upload simulation results to some storage that we have. But we're all looking at different aspects, maybe it's multidisciplinary sort of thing. Supposing that I wanted a simulation manager, something somewhere where I could provide information about the parameters or the factors that my simulations are looking at, and I want maybe for other, now I'm just wildly speculating, and I want some of my remote collaborators to be able to, say, take one of those sets of parameters, start from my data, decide what they need to run, looking for something else. I'm wondering if there's some kind of a future direction where there's some kind of a magic simulation manager where you can ask for things.
Is doing something similar. CL and Geneva, the accelerator. I think that they're doing something similar because they're running all the experiments on a daily basis and they're generating tons of data, which is actually accessible by all the physicists of the world.
Because with my work, and actually I'm working on a couple of different projects, I generate a lot of data, and a lot of it I hand off to people who don't care about OMNeT. They don't know about OMNeT, they don't care about OMNeT, they're not going to know or care about OMNeT.
Yeah.
And that's not negative about OMNeT. And it would be nice if there was some way to give them an interface, either to collect the data and say, so I was doing all this stuff, and can you look at these cases here because I don't understand what's going on, and I'm just handing them data. And they say, okay, they want these, and they go, can we look at these parameters here and send it back, and kind of send it back and get those.
This boils down to basically some some website or web service to collect the data, and then some format to
right. There needs to be
some way to
index, right? Some way to index or describe the collection of data that you have. I mean, right. So the whole user interface thing is user interface, but the idea if you have a whole collection of simulation out, well, a bunch of SQL data, I guess.
Maybe it's work on SQL. Maybe your work with the SQL is going towards that direction.
some standard which is accepted among researchers.
But there needs to be some way to index the data that all sent. Or to ask for
So, then we'll just... Yep. You're going to use your own laptops, or you want to do it on someone else? Perfect.
The presentation I'm going to say.
No, so HDMI or VGA. Perfect. I'll just take the PDF slides afterwards and then beforehand and then
Afterwards.
yeah.
So let's go.